So we're going to continue with section 8.8, adding and subtracting rational expressions. Let's just give ourselves a couple basic examples to work with first to kind of get into the flow a little bit. Let's start with 2/3 plus 1/4. Can I add these together and get, say, 3/7? No. Why not? What do you need before you add them together? Common denominator. So the first thing we need to do is determine a common denominator, an LCD, least common denominator. Between 3 and 4, what's the LCD? 12. So our common denominator is going to be 12. I want to write each of these as something over 12. So the way that I like to do these problems is this. I like to multiply by 1, something over itself. Now what do I multiply 3 by to get 12? 4. And if I do the same thing in the numerator as I do in the denominator, I'll get 8/12. And then likewise over here for 1/4 converted to something over 12, I'll multiply by 3 over 3. Once you have common denominators, hey, that's great. Just add the numerators, right? So 11/12. And that's it. If you have common denominators, you're in great shape. If you don't, then you're going to have to shore that up. So determine the LCD, convert to the LCD, and then add or subtract. So kind of 3 basic steps that you're going to have to follow in working with these things. Of course, if you have something that has an LCD to begin with, then hey, you're in great shape. Let's start with problem number 66. So 9x over x squared, excuse me, no, just 9x, not 9x squared. So a little Photoshop, there we go. 9x over x squared minus 9. More Photoshop. Minus 1. Minus 9 over x squared minus 1. Now that's nice because it has common denominators, right? And you can very quickly write this as 9x minus 9 over x squared minus 1. But hopefully you wouldn't leave it here, because you'd probably get about 1 point out of 4. Why not? What else should I do? Thank you. Let's factor out the numerator and denominator. What can I factor out of the numerator? A 9, which is behind x minus 1. And the denominator. What do I get when I factor that one? Good. X minus 1 times x plus 1. So x minus 1 times x plus 1. Yay. So from here, now I can see what else I have to do. I can cancel out that x minus 1, and I'm left with 9 over x plus 1. So that's your 4 points out of 4 points. But you should always look for that extra cancellation. I think Bailey, I think you were asking about, you know, the form, or do I have to write it as one fraction with another one? I said, yeah, you had to write it as one fraction, but it's convenient to leave this denominator factored so that you can see if there's any extra cancellation. So after you've written like this, you don't have to go back and multiply it together if you don't get any cancellation. Just leave it factored, it's fine. So keep it as friendly as possible. Let's try another one. It's a good follow-up to that. And what I want you to see in this one is that you really got to be careful with the negative sign. Problem 68. 5x plus 8 over 3x plus 15 minus 3x minus 2, again, over 3x plus 15. These have common denominators, and it's natural to put these two terms together with that common denominator. But if I wrote it like this, 5x plus 8 minus 3x minus 2, I'd be making a mistake. Very good. To try and see that, let's do this. Let's put a parenthesis around that numerator here. And then that parenthesis is right here. Before I combine like terms in the numerator, what do I have to do? Yeah, I have to distribute that. So if I distribute that, that's 5x plus 8 minus 3x plus 2. So in order to write that without parentheses, I have to distribute that to both terms. When I combine like terms in the numerator, I'm left with what? 2x plus 10 over 3x plus 15. Now am I done? No. What else do you see here? Factor out a 2 on top. Good. Nikaya, what can factor out, or how does a denominator factor? Good. So 2 times x plus 5 over 3 times x plus 5. And finally, a little more cancellation. You get 2/3. Now, unfortunately, if you make a mistake with that negative sign, if you don't distribute the negative properly, you'd end up with 2x plus 6, and you're not going to get any of this nice cancellation. So missing that negative sign on this one is really a costly mistake. It's just not much I can do to get around it. So that's why I take care to try and point out, what happens when you distribute that negative sign. Make sure that you change the sign on both terms so that you can get that final cancellation. All right, so those are a couple nice ones. They had common denominators. But what if you have something that doesn't have a common denominator? Well, then we're going to have to do a little bit more work. So we're going to have to convert to the LCD and then move on from there. So let's do a bunch of problems to try and give you some practice on that. Starting with problem number 70. Two over 5a plus 3 over 2a. Now, if you need some help finding a common denominator and practicing that, then you can look back on page 534. So, finding an LCD, page 534. Well, A is going to be part of our common denominator. What's the number part of our LCD going to be? 10. So I want to convert 2 over 5a to something over 10a, and 3 over 2a to something over 10a. Mackenzie, what should I multiply by in the first one? Good. So I'll multiply by 2 over 2 and get 4 over 10a. And then likewise, for the second one, I'll multiply by 5 over 5 and get 15 over 10a. This problem can be rewritten equivalently as 4 over 10a plus 15 over 10a. Now that they have common denominators, add the numerators, I get 19 over 10a. Is this in lowest terms? Actually, it is in lowest terms. What might be bothering you is that the numerator is bigger than the denominator, but there's nothing in common between both of these. There's nothing I can reduce. So it is in lowest terms. If you're really annoyed by the fact that the numerator is bigger than the denominator, you could write it as 1 and 9/10 times a. That'd be fine, but let's just keep it simple. Let's go with that first one. We okay on problem 70? All right. Let's try problem number 74. Kind of edging our way up here in terms of level of difficulty. So 1 over 5xy cubed minus 2 over 15x squared y. So this is a good chance to kind of go over / review how to find the lowest common denominator. And the way to question the LCD, yeah, the least common denominator. So the first thing you have to do is you have to factor these. Well, they're both pretty much factored, except if I really wanted to, I could write 15 as 3 times 5. So 5xy cubed and 3 times 5 times x squared y. So the first thing is to list all the different factors. Or excuse me, first thing is to factor it. Second thing is to list all the different factors. So there's a 3, a 5, an x, and a y. Well, this step is kind of a pain, because a lot of you just want to rush right to the answer. I understand that. If you don't want to do this step, that's fine. But the reason I encourage this step is because the next step is to multiply together the highest power of each factor. The highest power of 3 is 1. Highest power of 5 is 1. But where doing this step pays off some benefits is right here. What's the highest power of x? Just x squared, right? Highest power of y is a y cubed. So the reason I like you to do this is because then you pick up the highest power of each of these factors. All too often people want to say, oh, there's 3 of them here and 1 of them here. There should be 4 as part of the LCD. That's not true. The LCD is going to be 15x squared y cubed. So that's our LCD. Let's convert each of these to have the LCD. What am I missing here that I have here as part of my LCD? Yeah, an x squared and the 15. So what should I multiply by? What are the missing factors? Gil? Good, 3x. So I'll multiply the numerator and denominator by 3x. How about for this one? What am I missing here? Yeah, multiply by a y squared. I need to get 2 more y's to have my LCD. So, yay. That gives me 3x over 15x squared y cubed minus 2y squared over 15x squared y cubed. Perfect. That's exactly what I needed. I've got the LCD. You can combine the numerators. 3x minus 2y squared over 15x squared y cubed. There's nothing else I can do. There's no common factor. There's no cancellation with the denominator. That's it. We're done with 74. Yeah, please. Oh, that should be A second. Thank you. Yeah, this should be a second. Let's keep going with problem 78. Yes. Two over a plus 4 minus 6 over a plus 3. So we've been building towards this type of problem. This is the kind of stuff that I want you to be able to solve. I mean, all of these are things that are fair game, but this is close to kind of the sweet spot for this exam. Now, same 3 steps as before. We want to factor both denominators. Well, guess what? These are already factored. We got a plus 4 and a plus 3. They're already factored. If you listed a plus 4 and a plus 3, all right, that's great. The LCD is going to be the product of those factors to their highest power. What's the highest power of a plus 4? 1. What's the highest power of a plus 3? 1. Do you have to show that step? No. If you just wanted to write down that's the LCD, that's great. Certainly in a problem like this, I can envision you being able to see that without doing all this stuff. That's fine. Next job, though, is to convert to have the LCD. So let's work on that. What do I have to multiply the first one by to get the LCD? Good. A plus 3 over a plus 3. How about the second one? Thank you. A plus 4 over a plus 4. Let's distribute the 2 in the numerator and get 2a plus 6 over a plus 3 times a plus 4. Now over here, you've got 2 choices, and I'll let you make it. We could distribute the negative 6 and then be done with the negative. We can just add these. Or I can distribute the 6 and keep the subtraction there. Let's just distribute a 6. I'll get 6a plus 24 over a plus 3 times a plus 4. Yes?
Why wouldn't we, like, for the bottom stuff, why wouldn't we make the same numbers? Like, do you get what I'm saying?
You have to treat this, yeah,
12?
yeah, good. You have to treat this as one whole term. So it's not trying to get a common denominator just here. You have to get the whole, you have to treat this as one whole entity. So you can't look at it in little parts. Like, oh, okay, I've got the a in common, I need to get a 12 here. You have to regard that as one whole term. So this is no different than just having a 6 here and a 7 here, you know, to get a common denominator of 42. You just, yeah, you can't break it down into that small of a level. It's a good question. I mean, people want to do it, and I understand the inclination. Try and distribute that negative carefully. See if you can't simplify this a little bit. See what you come up with. So, give you a chance to work on that. Distribute that negative, collect like terms, etc. See if there's any more cancellation you can do with the denominator. by looking at the LCD and figuring out what more you need and introducing those terms. Okay. So when you distribute the 6, we get 6a plus 24. These are like terms. Well, excuse me, there are some like terms in the numerator, but we have to be careful about combining them. So let's write one big denominator, a plus 3 times a plus 4. And in the numerator, I've got 2a plus 6. And do you want to distribute the negative here? Negative 6a minus 24. Good. So now we can combine like terms. There's like terms here and here. So go ahead, Mindy. Negative 4a minus 18. And there is some factorization I can do in the numerator if I really was motivated. I could factor out a negative 2, for instance, which will leave behind 2a plus 9. But do I get any extra cancellation with the denominator? No. So I'm happy with either one. It's a good habit to be into, to look for that extra cancellation. But, you know, if you don't find it, okay. If you can see that, gee, you know, I'm not going to get any more cancellation, you can leave it like this. That's fine too. If you left it like this, that'd be fine. I have no problems with either one of those. Anything else on problem 78 here? Yeah. Oh, you could FOIL out the denominator. I mean, I got no issue with that. I guess the reason I like you to leave it is if I FOIL this out and got a squared plus 7a plus 12 in the denominator, how would I know if I'm going to get any cancellation? I don't. I'd have to factor this to see if I get any cancellation. So rather than multiply it and then factor it, I'll just leave it factored. All right. Anything else on 78? Let's try problem number 86. So 86, I'm going to want you guys to help each other out. I'll walk around and help out as well, but help each other out. It's 9 over 2r squared minus 2r minus 5 over 2r minus 2. There we go. First one with the right answer gets to do an extra 20 problems of homework. Go. All right. I'm still trying to perfect my reverse psychology. It's not there yet. factoring both denominators to get started to try and figure out what the common denominator is. There's a GCF for both of them. Try and factor that out and see what the LCD is. list all the different factors. So 2 and r minus 1. Okay, so let's take a careful look at these. Look, I'm not going to pretend that these are going to be your favorite problems in the world. They're not. But they are things that we can conquer. We're spending a lot of time on this because I want you to get it right. I'm doing a video because I want you to get these things right and have extra practice. So the first step is to factor each of the denominators. So let's do that. Out of this, I can factor out a 2 and an r, which leaves behind r minus 1. Out of this, I can factor out just a 2, which leaves behind r minus 1. So as far as my steps are concerned in terms of finding the lowest common denominator or least common denominator, I've got it factored. Next step is to list all the different factors that are here. Now, there's a 2, an r, and then this whole term. Don't break this up into, another factor of r and then a factor of minus 1. It's the whole term. So, comma, r minus 1. Are we okay with our list of factors? Let's multiply. Yeah, Kyle? Well, there's a times between each of these, and anything that's being multiplied, I mean, that's a factor, and 2 is a factor. R is a different factor. So all the different things that are being multiplied, each one of them is a factor. So this whole term, r minus 1, is a factor because that's something that's being multiplied. We don't want to break it down into the r here and the minus 1. It's just considered one whole factor. So appreciate the question. Last but not least, our LCD is going to be the product of each of these to their highest power. So the highest power of a 2 is 2 to the first. Highest power of r is just r to the first, and then an r minus 1. So that's your LCD. That's good news though, right? Why is that good news? It means there's nothing to do here, right? It's already got your LCD. Doesn't leave us a whole lot to do on this part either. What am I missing here that's part of my LCD? Just r. So I can multiply by r over r, and then I've got my LCD there. So I've got 9 over 2r times r minus 1 minus 5r over 2r times r minus 1. I just changed the order there. That's fine. I've got my LCDs. I can subtract the numerators. 9 minus 5r over 2r times r minus 1. And that's it. There's no more simplification on that one. Whew. Take a deep breath. Get the oxygen bottle, all right? Let's see. Do we want to do one more finding the LCD there? Or working with that kind of thing? Yeah, there are a couple more problems. These go into rational equations. So the unfortunate part about the early part of this course is that there's a lot of stuff that's review. So we do get to cover a lot of stuff kind of quickly. But fortunately today we do have the time to do that. So let's try problem number 90. So these are changing things up a little bit. We're going to work with rational equations. The difference is that in addition to our rational expressions, we're going to have an equal sign somewhere in the problem. And when you have an equal sign, that's going to mean you have to solve your equation. You have to find a value for x. So for problem number 90, we've got 2 over x plus 1 over 2 equals 7 over 2x. This is going to be much different than our work with rational expressions in terms of adding and subtracting them. Because we have an equation, we can get rid of our common, we can get rid of the denominators altogether, because we can multiply both sides of the equation by the LCD. So what's the lowest common denominator for all three of these? 2x. So unlike our work with rational expressions, because I have an equation, I can multiply both sides by 2x. Here by 2x and here by 2x. Now on the left-hand side, when I multiply the left-hand side by 2x, that 2x really distributes itself to both terms. So I'll get 2x times this and 2x times this. In other words, your LCD multiplies everything. And the nice thing that's going to come out of this is that I won't have any fractions left. Let's see what kind of simplification I get. So, Rachel, what's going to simplify with the first two? Yeah, so just 4 over 1 or 4. 4 plus what? Four plus what? Anyone? X equals 7. Wow. 4 plus x equals 7. Can anyone tell me what x equals? X equals 3. Wow.
That was easy.
That wasn't too bad. Just multiply by the common denominator, and that was pretty much it. So the big thing for you in these is going to be to figure out the correct LCD. There's one more little thing that you're going to be asked to do. Make sure that your answer doesn't give you a 0 in any of these denominators when you put it back in. If it does, you have to throw that solution out. It'll be what's called an extraneous solution. Let's try some more. Problem number 92. Seven over 5x minus 1/2 equals 5 over 6x plus 1/3. All right, a little bit more work here, Amila, to figure out what the LCD is going to be. 30, good, 30x. So our LCD is 30x. All right, good. So everything here is going to get multiplied by that LCD. And if we chose our LCD correctly, then we shouldn't have any fractions left after we finish that multiplication. So let's see here. Everything's going to get multiplied through by 30x. So 30x here, 30x here, 30x here, and 30x here. If it helps you, maybe think of it as 30x over 1, so that you get some cancellation there. See what you can come up with in terms of your cancellation. Kyle, what cancels from the first two? x's. Anything else? Good. 5 goes into 30 6 times. 6 times 7 will be 42. So 42. Good. Let's keep going. Called in yet today? No, go ahead.
2 cancel.
Good. 2 goes into 30 15 times. So, and 15 times 1 is just 15. X is still here though, right? Good. How about the right-hand side of the equation? What I picked on today. Norman, thanks for volunteering. All right, so I cancel. I get a 5 here. And what else disappears? Yep, the x's. So I'm left with 5 times 5 is 25 plus, anyone? 10x, good. So 10x. Whew. All right, so but with one step, we've gotten rid of all of our fractions. So that's kind of nice. The rest of it, this is just a linear equation. I'll add 15x to both sides. That'll put my variable here. And let's be kind of a little bit efficient with this one. When I have the variable on this side, I want to put the constants on this side. So I'll subtract 25 and get 25x equals 17. So 17 over 25 is equal to x. Now, if you were to look back at the original problem, 17 over 25 is not going to create an issue with the denominators. The only value of x that would create an issue would be x equals 0. But that's not what we got for our solution. Whew. Almost done. So one last one for this section, and then I'll take it easy on you in section 8.9. Any wrap-up or thoughts on problem number 92? Last one would be number 96. To try and get through this one a little bit faster, if it's okay with you, I'm going to write down the denominators already factored. It's 3 over 2x plus 4. But let me just take the time to factor out the denominator for you a little bit. Let's just pull out the GCF. So 3 over 2 times x plus 2. Let me just make sure I get this one right. I think it's equals. Yeah, equals x minus 2 over 2 plus x minus 5 again over 2 times x plus 2 term like that. So I took the liberty of factoring out the GCF from these two denominators. So our denominators are factored. What's the GCF for this problem? Good. Here it is right here. It's 2 times x plus 2. So that GCF is going to have to multiply each of these terms here. So I'll squeeze this in here. 2 times x plus 2. 2 times x plus 2. And 2 times x plus 2. So that GCF is going to multiply each of your denominators. I can do that because this is an equation. I don't have to get common denominators and add like expressions. I can just get rid of the denominators altogether. On the left-hand side, the 2x plus, or 2 times x plus 2 terms cancel. What's left? Just the 3 from the numerator. And on the right-hand side, let's do the easy one first. I'll be left with an x minus 5 over here. What happens with the middle term? Good. The 2's cancel, You're left with x plus 2 times x minus 2. Let's FOIL those out. I'm left with 3 equals x squared minus 4 plus x minus 5. So combining the like terms there, basically these cancel. I can combine some more like terms. X squared plus x minus 9. This is a quadratic equation. So get 0 on one side. And then see if you can't factor that. Does x squared plus x minus 12 factor? Sure. You're looking for two numbers that multiply to negative 12 and add positive 1. What would two such numbers be? All right, 3 and 4. Which one's positive, which one's negative? Yeah, negative 3, positive 4. The larger of them has to have that sign. So I got x minus 3 times x plus 4. There's two possible solutions here. Can anyone read those off? Good. 3 or negative 4. Those are your two solutions. Neither of those causes a problem with the original problem, so we're okay with those. The only thing that would give us issues would be x equal negative 2. That would cause a 0 in the denominator. Whew! Get out the oxygen bottle. Good job on this section. We are done with it. Yeah, please.
Why is the x, like, for the answer, why would x be negative 4 instead of, like, positive 4?
Good question. Let me grab another sheet here. When you're multiplying these things together, you get 0. One of these, either x minus 3 has to be 0 or x plus 4 has to equal 0, right? Because the product of those is 0. So when does x minus 3 equal 0? Well, if I add 3 to both sides, I get x equal 3. If I subtract 4 from both sides, I get x equal negative 4. So the quick thing to do when you're solving these quadratics by factoring is to just change this sign to jump down to here. Okay? Appreciate the question on that one. For homework, try 25 through 25 and 27, 33 through 53, 59 through 83, 89 through 93, 101 through 107, and 111. So that's 34 problems out of the 144 that the book has. So I'm less than 25%. So it's not too bad. Whew. Wow. All done.